Okay, so there are two different situations. One in which f of negative x equals the identical function, the function we started with, and the other one which is f of negative x, which is the opposite of f of x. These are the only two options. This is for an even, and this is for an odd. As you see, in both situations, we have to calculate or determine f of negative x. That is the starting point. So what does f of negative x mean? How do I determine f of negative x? In the same way I determine f of 5.
You substitute negative x.
Right. So I just want to make sure that there is no confusion. Y or f of x mean the same thing. So when I determine f of 5, all I have to do is plug in 5 for x. But when I need to determine f of negative x, all I have to do is the same thing, which means the fifth root of 8 minus, what do I put in here?
Negative x squared.
Negative x and everything squared. Perfect. It's the same process as if we are evaluating for any other number. But this time we are evaluating for negative x. So now, what is negative x to the second power? What does this equal to?
X squared.
Perfect, because it's negative x times negative x, which is x squared. So then the answer is the fifth root of 8 minus x squared. At this point, I'm asking myself three questions. Is this the identical f of x, which is the fifth root of 8 minus x squared? Does this equal the negative f of x, which will be negative the fifth root of 8 minus x squared? Or none of the above? So there is a yes only for one of these three, and two no's. One yes, two no's. Which one is yes?
Even.
Yes. So this function is even. This is not the case, and this is not the case. This is correct. So I evaluated f at negative x, and it happened that the answer was completely simplified back to the original function. Done. The function is even, which means that if we need to graph it, it will be symmetric with respect to the y-axis. Awesome. Well done. Okay, I think we should graph another piecewise defined function. Do you agree?
Yes.
Okay, very good. So let's look at, let's say, problem 62. And this is on page 252. And we have f of x, which is 1/2 x, if x is less than or equal to 0, and is 3 if x is greater than 0. If you remember from last time, whenever we are asked to graph a function, what is the first step, the first thought, the first idea that comes to my mind? The very first one is to find what? Every time you give me a function, you ask me to graph it, my first thought must be the, say it again? I think I heard it.
Domain.
Thank you very much. Without the domain, I cannot start, I will not start. It doesn't mean anything. That is awesome. Thank you. So therefore, I will replace this by what interval? What interval? To 0 with a bracket. Awesome. And then I'll replace this. You don't have to cross it out. I'm just making a point.
0
to infinity. And now we can, from here, I think it's easier to identify the domain. Number one. Number two, I need those symbols for the table. So can anyone identify the domain of this function? Say it again.
Negative infinity with the 0 with the bracket.
So that's why we established those intervals to see what's happening from negative infinity to 0, including 0, and from 0 to infinity, which means the domain is all real numbers. Any questions, please ask. Which is the x value that has to be in the table no matter what? Yes, 0 must be in the table no matter what, and furthermore, it must be in the table right now because at 0, something very important happens. The function changes from one piece into another. So now you see these symbols. That's the second reason why I replaced the inequality by the interval notation. Exactly under 0, these two symbols are touching. The bracket is opening to the left because that's what I have here. And the parenthesis is opening to the right because that's what I have here. Now, I know that this is an overkill. It's not necessary, but I highly recommend it because the two branches in this case, or maybe three branches, may not be presented in the correct order. So now, can anyone tell us which branch or which function we will be using between negative infinity and 0? Only one.
The top one.
The top one. Very good. So it's 1/2 x. Which function we will be using from 0 to infinity? Of course, it's a silly question. There are only two branches. Very good. Awesome. What type of function is this? Perfect. So please give me another value here. Something nice that I can divide by 2.
-2.
-2 is good. 4 is not because 4 is not here. That's okay. So -2 is perfect. So -2 times 1/2, the answer is -1.
Negative.
So let's plug in 0 here. What do we get? 0. And please write it right inside the bracket in the middle. And now let's plug in 0 in the second branch and tell me what you get, and write the answer inside the parenthesis.
3.
Good. And let's choose another one because it's still linear. And please tell me what you get when x is 1.
4. And we'll get 3. Oh, 1.
Of course. Of course. For any number between 0 and infinity, you get 3. Very good. So now let's graph from left to right. Please give me the first ordered pair that you will ask me to plot, or you will plot. First ordered pair is from left to right.
Left to right. Okay. -2, -1.
Very good. The next ordered pair, please.
0, 0.
What type of point is 0, 0?
You're gonna do a solid.
It's a solid or a full point. Very good. And we are done with the left branch, not to be extended to the right. Okay, on the other side, can anyone give us the next point? Next point. Next point. Very good. 1, 2, 3. Is it an open point or a full point?
Open.
Very good. And then at 1 is also 3, but this is full. It's in the middle of the interval. So this is the piecewise defined function. Can anyone give us the domain or identify the domain, not the domain, forgive me, the range of this function?
Negative infinity with a parenthesis on the front part of the negative infinity to 0 capped off. And then 1, 2, 3.
That's it. And union and nothing else. Very good. Okay. Any questions, please? Any questions? Anything? Anything? Okay, so let's take a look at the following function. Let's say I have a graph. This is function f of x. And let's suppose I have 2 points on this function. Point P, and let's say point Q. And the x coordinate of P is x. Can anyone give us the y coordinate of P? So this is a point on the graph. The function is f of x. If I say x is 5, how will you find the y value?
It looks like it's about 5.
So if x is 5, how will you get the value for y? If I have a function, any function, don't think of the particular function, just any function. I have a function f of x, and I'm telling you I have x, x is 5. Please determine the y value. Thank you. So f of x. And let's say we have x plus h. That's the x coordinate of q. Can anyone give us the y coordinate of q? Anyone but Mallory? Anyone? Excellent. Thank you, Gabe. F of x plus h. Awesome. Now I would like you to give me the slope of this line. So this is this what I would like to determine the slope of line PQ. So this is a secant line, meaning a line that crosses the graph in 2 points. That's all. Can anyone refresh our memory how we get the slope of a line passing through 2 points? Yes, anyone?
The change in y over the change in x.
Very good. So it's y2 minus y1 over x2 minus x1. For our particular example, can anyone give us y2?
So we going back and put
Y2 is f of x plus h.
Awesome. Minus
No, this
y1.
The x is 0 at the bottom.
Very good. Over x2 minus x1. So this is x, f of x. X is x1, and this is y1. Q, this is x1, and this is y2. Y2 minus y1, the rise, y2 minus y1 over the run, x2 minus x1, as we know from lines. Is this okay, everyone?
So you put on the bottom, you put x plus h minus x. It doesn't matter if you like.
Of course. Y2 minus y1 over x2 minus x1. They have to be in that order.
Okay, so the h minus x at the bottom, did it say, because you put x plus h?
Yes.
Does that matter? Like if I put x plus h, I'm confusing myself. X plus h on the bottom, would that be wrong? Because
Yes, because these two will go away. You have to subtract.
x is x1, it has to go in that order. Does that make sense? Like, see
So x plus h with x plus h, x with x.
They can't cancel out because they're not the same. They're representative.
So if you look right above it in red where it says x plus h, that represents x2. So that by itself is x2, and then x1 is that first x, so it has to go in that order. They're two different things. Okay.
Does it make sense now?
I think so.
Okay, perfect. So it happens that these two go away. So the simplified form is f of x plus h minus f of x divided by h. This has a very important name. It's a very important expression. It has a name. Difference quotient. It gives us the rate of change of this function when there is a change in x. So it represents the rate of change of f of x between p and q. You do not need to memorize it. It will be given to you. In this class, you don't have to memorize it. Our next step is to choose several functions and determine the difference quotient. Okay? So you're not required to memorize this formula. It will be given to you. But let's apply it in several functions. Like, let's say problem 78 on page 252. And the function is x squared minus 5x plus 8. Let's go back for a moment. Do you have any questions on this? Do you have any questions on this? So the rise is y2 minus y1, and the run is x2 minus x1. Okay, everyone with me? Yes? Okay, so here's our function. We're asked to find the difference quotient, dq, which will be given to us as a formula, f of x plus h minus f of x divided by h. I see three pieces here. It's very important to understand the mechanism. I see three pieces. This is one piece, this is another, and this is the third one. Two of these two pieces you cannot do anything to. Can anyone identify which of these three pieces we cannot touch? We cannot do anything to. And which one we have to work on first?
No way to figure out what x plus h is.
Nope.
Like if you take h.
Age is, I cannot do anything. Can I do anything to it? I cannot even touch it. No. Age is just age. There is nothing I can do to it. I cannot simplify, I cannot touch age. What else I cannot touch? Of course, the function. There is nothing I can do to this. It's just this. I will have to copy it. So this piece will be x squared minus 5x plus 8 with minus in front. All signs will change. So these two are fixed. Any questions, please? I hear talking in the back. I can't have that. Please, please. Please ask. Anything. Anything. You may have a question that is on other people's minds. And when I see clothes and jackets and backpacks, then I know you're not paying attention. So if you want to put them away, please, 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 please. There is no need to have all those on the table, unless you have something to hide. Okay, so this is fixed. No one can touch. This is fixed. No one can touch. This is the only piece we don't have. So can anyone dictate? How do I determine f of x plus h? It all depends on the function. The function says f of whatever is whatever squared minus 5 times whatever plus 8. It's the same thing as I would need to do when evaluating this function for x equals 5. I don't evaluate it for x equals 5. I evaluate it for x plus h now. Can anyone dictate the first step? Good, I'm ready. But can anyone dictate the first step?
X plus h squared.
Very good, awesome.
Minus 5x plus 8
Awesome. Plus,
plus 8.
that's it. Great. So although this is not done, this is our first step. Why is it not done? Because we have to fully simplify it as much as we can and then put the piece in here. So whatever we come up with, it's going to replace all this. Then I replace f of x with this, and then h has to stay as is. Two things have to happen when we determine and simplify the difference quotient. If we need to write them down, we will write them down. Two things. The first thing that has to happen right after we put everything together is all terms without h from the top must go away. If other terms go away, that's even better. That's a bonus. But definitely terms, and I'm going to say this several times, and we're going to write it together. All terms without h from the numerator have to go away. Eventually, the second thing that has to happen, eventually this h will go away. So, but we're not there yet. So can anyone give us this?
X squared plus 2x plus h squared.
Excellent. I'm sure everyone heard that. Thank you very much, Stephanie. I really appreciate it. This is what we did on the first day of classes. Wonderful. Thank you. Okay, so now there's nothing we can do here. Yes, any questions? Please ask. Any questions? Yes?
Where did 2x be out of that?
Can anyone tell us where the 2 is coming from? This is the
Because
6th week
you
of
made
class.
the deal like the a squared would be like where the x squared is, and b squared on the right side is where the b would go, and in the middle is 2ab, and 2ab in this case would be 2x.
Thank you.
A squared plus 2a squared plus 2ab plus b squared. A squared minus 2ab plus b squared. This was the first day. This is the first day. Please, please, please. It pops up every class, more than once. So please make the effort, please. Okay, so now all we have to do, I'm going to continue here. All we have to do is just replace this piece with everything you see here. So this is x squared plus 2xh plus h squared minus 5x minus 5h plus 8. I just copied this. This piece is everything we just determined. But now remember, there is a minus that needs to be distributed to these three terms. So then I have negative x squared plus 5x minus 8 and h in the denominator. Any questions, please?
Yeah. Would you just, the second part you just did?
See right here, how this is negative f of x. This is negative f of x.
You
So
said
if you put the negative through it, it has to be
distributed.
this we took.
If I have minus in front of a quantity,
and we're putting it like
if I have minus in front of a quantity, don't I distribute negative sign to all?
that word, and so we're just adding that, but we had to distribute the negative. Okay.
Negative 1 times x squared, negative 1 times negative 5x, negative 1 times 8.
Okay, and that's for like the other half.
This is this piece right here. This piece is this. Okay, so now two things have to happen. Yes, Lani, go ahead. Any questions? Is this okay, everyone? Okay. So first thing has to happen, all terms without h must go away. If more terms go away, it's even better, bonus. But all terms without h must go away, and they do. Next step that has to happen, this somehow must go away. How many terms are left at the top?
3.
Perfect. They all have to have what in common so that eventually, indeed. How many terms will you write at the top?
3.
Excellent, because we started with 3. Great job. So what do I have in parentheses? Excellent. Good. This is the only time I can simplify because I simplify factors, and the answer is 2x plus h minus 5. So notice that there is still an h left over, but that's okay. It's not the one from the denominator. So every time we determine and simplify the difference quotient, two things must happen. If you want me to write them down, I will. So number one, all terms without h from the numerator have to go away. Second thing that has to happen, otherwise we have an error somewhere, is this h in the denominator must go away. In other words, must be simplified. But there could be, and it will be, an h or h left in this final expression. So number one, all terms without h must go away, must simplify. You know what I mean. And number two, h from the denominator must simplify as well with a factor from the top. So one more time, number one, all terms without h must simplify, must cancel out. And number two, h from the denominator must simplify as well with a factor from the top. Must simplify with an h from the top, from the numerator. As a factor, must be a factor. You cannot just simplify it inside a term. Must be a factor. Okay, that's all I had to say about this section. If you would like, we can look at another difference quotient situation. Is that something you wanted? So one more time, all terms without h must simplify, and h from the denominator must simplify with an h from the numerator as a factor. I should write better. As a factor. Not inside terms. Okay, would you like to illustrate with another function? Okay, would you like to choose another function, or do you want me to choose? You would like to choose, or you want me to choose?
You can choose.
Okay, let's say 82. So we have f of x, maybe better 80. 3x squared plus x plus 5. I'm going to change you with negative x to negative x, negative 3. So it's not 80 anymore. We just made one up. Okay, so we are asked to simplify the difference quotient. Difference quotient. I will always write it. It will be given to you. So this is f of x plus h minus f of x divided by h. From these three pieces, which one do I have to work on? Because I don't have it yet.
F of X.
Right, that's the piece that I have to work on. Perfect. So let's work on it on the side, and then we'll come back. So how much is f of x plus h? Can anyone dictate?
Negative 3 x plus h squared.
In parentheses, very good. Plus x plus h, it doesn't need parentheses, plus 5. Is this clear for everyone, to everyone? Is this okay?
Yeah.
Yes, everyone?
Yeah.
Awesome. So now I have to square first. I have to copy negative 3 and I have to replace this by, can anyone dictate? Thank you very much. Plus x plus h plus 5. Only now I can distribute negative 3 to these three terms, not before. By the order of operations, we have to square first and then distribute or multiply. So then this is negative 3x squared minus 6xh minus 3h squared plus x plus h and plus 5. Finally, we have all three pieces. Now we have this, and we have this. All we have to do next is just put them together and simplify. And remember, two things have to happen. Can anyone refresh our memory on the two things that have to happen? In order. That's very important, in order. The first thing that has to happen is,
All terms of H.
from the top, from the numerator, must cancel out. If they don't, we know we have a mistake and we have to go back to the drawing board from scratch. What is the second thing that has to happen after the first thing happens?
You have to factor out the term of h.
Because the h in the denominator must simplify. Yes. For all difference quotients, for all functions, all the time. These two things have to happen. So then I continue here. So let's try, I will try to fit everything in. Negative 3x squared minus 6xh minus 3h squared plus x plus h plus 5. Remember now we reached the negative sign, negative 1, that has to be multiplied or distributed to all three terms. Can anyone dictate what to write?
Plus 3x squared minus x minus 5.
Excellent.
Oh, the second. Okay.
So now remember we have three terms that have to go away, and they do. These two, three pairs, I should have said, three pairs of terms. They do go away. How many terms are left? Good. Do they all have h in common? If not, we know there is a problem. And we have to go back and reassess the situation. How many terms we have inside? Yes, negative 6x.
Minus 3h squared, or minus 3h plus 1.
Excellent. So as expected, the second thing just happened. H in the denominator went away with the factor from the top.
Because h is by itself up there, and when you pull h out, it leaves 1.
That's the reason why I asked how many terms you expect, so you don't omit the one. So always ask yourselves how many terms I have. If I omit this, how can I get back three terms, right? If I distribute h to these two, I will never get three terms.
And that's positive h. So when you take the h out,
Is that okay? Good. So please practice with the difference quotient with any function. You can have rational functions and so on and so forth if you want. Oh, we only did two examples with what kind of function is this? What kind of function is this?
linear, quadratic.
Quadratic, awesome. Very good.
So these are different functions, right?
Quadratic function.
So it's
Quadratic
defining
function.
different functions.
To find the difference quotient. Correct, yes. 2.3 and 2.5 are both review, and they are connected. I'm sorry?
You mean 2.4? You said 2.4.
I said something else?
You said 2.3 and 2.5 were
Oh. No reason. Sorry, my apologies. So this is all about lines. Lines. And we already went through this, so let me refresh our memory. We have y equals mx plus b, which is slope-intercept form. I like to call it Y-intercept form. We have y minus y1 equals the slope times x minus x1. Anyone remembers what is the name of this?
Point slope.
Thank you. We just used a few minutes ago the slope y2 minus y1 over x2 minus x1. This is the slope given 2 points.
Are we gonna need to memorize these?
Yes, please.
Okay.
Now, two parallel lines. The slope of the first one is m1, the slope of the second one is m2, parallel. What is the relationship between the slopes for parallel lines?
They're the same.
Very good. m1 equals m2. What if they are perpendicular lines?
The opposite reciprocal.
Negative. Very good. So this is 90 degrees, 90 degrees, 90 degrees, 90 degrees. So these are perpendicular. So this is m1 and this is m2. So Mallory likes to remember it as m1 equals -1 over m2. That's perfect. I remember it, I think, much easier. The product equals -1. Just cross multiply. And that's what you get. For me, it's even easier to say, don't forget what you want to say. It's even easier to say the product equals -1. This one, you have to say the slope of the first line is the negative reciprocal of the slope of the second one. Here, you can just say the product is -1. Yes, please.
So the parallel lines there, just will all be the same. What did you say about parallel? Because they'll all be the same.
They are the same. Okay, so let's also look at the types of slopes. Types of slopes. Or I should say types of lines. Better. Okay, what kind of slope will this be? What kind of slope will this line have?
Positive.
Very good. The slope is positive. What about here?
0.
Neutral.
Yes. What about here?
Negative.
Yes.
And undefined.
Very good. Slope is undefined. That's all we needed for these two sections, 2.3 and 2.4.
So if you see a line that's going diagonally upward, it's gonna have a positive slope. And if you see one that's just straight a horizontal line, this will be 0. And then if it's negative, if it's downward, it's gonna have a -1. And then a vertical line is just undefined.
Any questions? Go ahead. Any questions? Anyone? Okay, so let's practice. For example, here's our first question. Let's say number 4 on page 267. We are given 2 points, -1, 3, and 2, 4. And we're asked to find the equation of the line passing through these two. Find the equation. The equation of the line. What do we have to find first? Yes, we will have to find a slope. What I would do first is I would name them x1, y1, and x2, y2. This is what I recommend as the starting point. And then you will not forget, if you write the equation or the formula for the slope, x2 minus x1, then you will write 4 minus 3 over 2 plus 1. And the top is 1 and the bottom is 3. Any questions so far on finding the slope? Is this okay so far? Okay, so now remember we have 2 options. We have this option and we have this option. Now, what is this?
Y-intercept.
Correct. So this is 0, a number, the y-intercept. if I do not have, if none of the points that are given to us is 0 comma a number, I will not think of this. I know there is a way, it's something like doing this instead of doing this, but it's up to you. I'll accept it. I'll never show something like that. So if it's not wrong, by the way. So if I'm not given 0 comma a number and I don't have 0 comma a number, I will not use the equation of slope-intercept form. I will use the point slope form. And you can use any point you like. So y minus y1 equals the slope times x minus x1. Forgive me, Mallory, I didn't hear what you said.
Oh, would you put 0 in for x?
Do you want to find the y-intercept?
Oh, no, yeah.
There is no need.
Okay.
You're going to find it anyway.
That's-
Yes, please.
Why the x2 minus, why did you put 2 plus 3?
Minus in front of -1 becomes positive.
Okay.
So now I have the slope, which is 1/3, and I'm using the first point, -1 and 3. And now I put everything together as y minus 3 equals 1/3 x plus 1. There is minus minus, it changes into plus. So I distribute 1/3 x plus 1/3, and remember we have to bring 3 to the other side. The equation has to be solved for y. And now there is no need to find the y-intercept. I will find it even if I don't want to. Here's the y-intercept. When we add 3 to 1/3, what do we get? The least common denominator is,
3
and what do we need for the adjustment for the top?
or 3, but it's
Yes.
9.
Very good. So 10/3. What does this represent? Is the equation of the line passing through the given point. Any questions?